Matt Armstrong sits inside the rebuilt Bugatti Chiron Per Sport, while cameras surround the workshop, and millions of people wait online to see what happens next. The engine that once looked completely destroyed is now alive again. The dashboard glows in front of him, and for a moment the entire project almost feels finished. You can hear the excitement in the workshop, because earlier in the rebuild many people believed this exact scene would never happen. A crashed Bugatti abandoned by factory. Support was never supposed to return to life inside an independent garage. Yet here is Matt, sitting behind the wheel of one of the world's most expensive hypercars after months of repairs, fabrication work, and endless controversy. But even during this huge moment, there is still a strange tension surrounding the car. The engine may be running. The cooling system may finally be working, and a first drive may be getting closer. But serious questions still remain hidden underneath the surface of the rebuild. That is why this story has become much bigger than simply fixing a damaged car. The story of Matt Armstrong rebuilding a crashed Bugatti Chiron Per Sport has become one of the biggest automotive stories on YouTube. Millions of people have watched the rebuild from the very beginning, and every new episode creates huge discussions online. Some viewers believe Matt has already proven everyone wrong by getting the car running again. Others believe the real problems are only starting to appear now that the rebuild is moving closer to a first drive. That disagreement is exactly why the project has become so interesting. Most car rebuilds are simple stories. A damaged car gets repaired, the engine starts, the owner celebrates, and the project ends. But this Bugatti rebuild feels completely different because the car itself is different. The Bugatti Chiron Per Sport is not just another supercar. It is one of the most advanced road cars ever built. It uses an enormous 8-liter W16 engine with 4 turbochargers, a highly complex cooling system, advanced electronics, custom-built chassis parts, and carefully engineered safety systems that all work together. When the car crashed, many people believed it would never return to the road. The damage was massive, and Bugatti reportedly refused to support the rebuild with factory help or replacement parts. That decision changed everything. Instead of becoming a normal repair project, the rebuild became a public challenge against the idea that only a factory can repair a modern hypercar properly. Every episode now feels bigger than just fixing a car. It feels like a debate about engineering, certification, safety, and whether independent workshops can truly rebuild machines that manufacturers treat almost like untouchable technology. Matt Armstrong supporters see the rebuild as proof that skill and determination can overcome corporate limitations. The critics see something else. They see a project that may look complete on camera, while still carrying serious unanswered questions underneath the surface. That tension is what keeps viewers watching. The car running to temperature was treated by many fans as the final victory moment. Social media exploded with excitement because hearing the W16 engine come alive again felt almost impossible earlier in the project. Watching coolant flow through repaired systems and seeing the engine hold temperature created a powerful emotional moment. But emotions can sometimes make people ignore important details. Just because an engine runs does not automatically mean the entire car is safe, reliable, or fully restored to factory condition. That difference between functioning and being fully verified has become the center of the entire conversation surrounding this rebuild. The project is no longer simply about whether Matt can physically repair broken components. It is now about whether anybody outside Bugatti can truly restore a Chiron to the standards the original engineers intended. That is a much more difficult question to answer. The deeper the rebuild goes, the more complicated the answers become. Some repairs look incredibly impressive, especially considering the lack of factory support. Yet every successful repair also creates another question. How do you fully test custom fabricated parts on a car capable of extreme speeds and enormous mechanical stress? How do you guarantee the safety systems still behave exactly as intended after major crash damage? And perhaps the biggest question of all is whether this Bugatti will ever stop being known as the crashed Chiron rebuild on YouTube. Even if the car eventually drives perfectly, its history can never be erased. Millions of viewers have already watched every damaged panel removed, every welded chassis section repaired, every questionable moment analyzed in public. That public history changes the car forever. Instead of being just another Bugatti Chiron Per Sport, It had become a symbol of controversy, ambition, engineering skill, and risk all at the same time. That unique position is why the rebuild feels bigger than a normal automotive project. People are not simply watching a car return to life. They are watching a debate unfold in real time about what modern hypercars really are, who should be allowed to repair them, and whether perfection can ever truly be recreated outside the walls of the factory that originally built them. Point one of the biggest moments in the rebuild came from something many viewers probably expected to be simple: the passenger airbag. At first, airbags do not sound very exciting compared to massive turbocharged engines or hand-built chassis repairs. But this part of the rebuild suddenly turned into one of the most controversial discussions of the entire project because it raised questions that nobody could fully answer. Earlier in the rebuild, mate Rimac, whose company now controls Bugatti, explained why he believed repairing a Chiron outside factory conditions was extremely difficult and potentially unsafe. Many people online simplified his comments and acted as though Bugatti was simply being arrogant or protective about its brand image. But his real argument was more technical and much more uncomfortable to think about. Modern safety systems are not just collections of separate parts. They are complete systems designed to work together under exact conditions. Airbags, crash sensors, seatbelt tensioners, electronic controls, and dashboard structures are all engineered and tested together. If even one part changes, the behavior of the entire system can also change. That concern became much more serious when Matt discovered markings on the back of the Chiron's passenger airbag that linked it to a standard Audi A3 component from within the Volkswagen Group parts catalog. The discovery shocked viewers because people naturally expect a multi-million-pound Bugatti to use completely unique parts designed specifically for the car. Finding what appeared to be an Audi component inside one of the world's most exclusive hypercars felt surprising and almost funny to many viewers. Matt ordered the matching Audi airbag, compared to the original, and found that it physically matched perfectly. The shape looked the same, the mounting points aligned correctly, and the part number appeared identical. To many fans, this looked like complete proof that Bugatti was exaggerating the complexity of the rebuild. But the situation is not actually that simple. Physical compatibility does not automatically guarantee functional compatibility during a crash. An airbag's entire purpose is to deploy in the correct direction at the correct speed and at the correct moment during an accident. It also needs to communicate properly with the car's crash sensors and electronic systems. Even tiny differences in calibration can completely change how the system behaves during a real impact. The problem is that there is almost no practical way to fully verify the replacement without crash testing the actual car, something that obviously will never happen. This leaves the project in a strange middle ground. The replacement airbag appears correct. It fits correctly. It may even function correctly. But nobody outside the original engineering teams can fully certify that it will behave exactly the same way under real crash conditions. That uncertainty is the real issue critics keep returning to throughout the rebuild. Supporters argue that manufacturers reuse components all the time, and that the matching part proves the system is less unique than Bugatti suggested. Skeptics respond by saying that shared components do not remove the need for complete system validation. Both sides have reasonable arguments, which is why the debate refuses to disappear. The airbag discussion also exposed a bigger truth about modern hypercars. People often imagine these cars as magical machines filled entirely with custom-built parts. In reality, many manufacturers share hidden components across multiple brands to reduce costs and simplify production. However, what makes a hypercar special is often not the individual parts themselves, but the way everything is integrated and calibrated together. That is exactly where the uncertainty surrounding this rebuild still exists. Nobody doubts that Matt Armstrong and his team are talented. The real question is whether talent alone can fully replace the massive engineering and testing resources of a global manufacturer. The airbag issue became the perfect example of that larger debate because it showed how difficult it is to separate looking correct from actually being verified. The interior rebuild became another moment where the project started to feel less like a normal repair and more like the creation of an entirely new identity for the car. When the crash happened, the deployment of the airbags destroyed large parts of the dashboard and steering wheel. Damage like that cannot simply be cleaned or hidden. The entire interior needed serious reconstruction work. Matt sent the damaged interior pieces to E3 Customs, and what came back surprised many viewers, because the final design looked completely different from the original Bugatti specification. Before the accident, the Chiron Per Sport used a much darker and more traditional luxury design with black leather, black Alcantara, and bronze details. After the rebuild, the interior featured bold purple and white leather patterns along with completely custom stitching throughout the cabin. Some people immediately criticized the change because they believed a rare hypercar should remain as close to factory condition as possible. To traditional collectors, originality matters enormously, especially with limited production cars worth millions of pounds. But the more you think about this particular Bugatti, the more understandable the custom approach becomes. This car will never again exist as a hidden or untouched factory example. Its crash history is public. The rebuild process is public. The fabricated parts are public. Millions of people now recognize this car specifically because it was damaged and rebuilt outside factory support. Pretending it could quietly return to being a completely original Chiron Per Sport no longer makes much sense. In some ways, the custom interior almost feels more honest than trying to recreate the original design perfectly. Instead of hiding the car's history, the new interior openly embraces the idea that this Bugatti has become something different from what it once was. That change in identity is probably unavoidable after such a public rebuild. However, beneath the visual changes, the interior also revealed another deeply technical challenge most viewers initially overlooked. The dashboard had to be rebuilt with hidden weak points designed specifically for the airbag deployment path. Modern dashboards are carefully engineered, so the material breaks in controlled ways during a crash. If the material is too strong, the airbag may not deploy correctly. If it is too weak, the dashboard could fail improperly. E3 Customs reportedly recreated these hidden weakening points using laser techniques, so they remain invisible from the outside while still functioning correctly underneath the leather. That detail perfectly captures why this rebuild fascinates so many people. The visible craftsmanship looks incredible, but the truly important work often exists underneath surfaces viewers can barely see. It also highlights the constant uncertainty surrounding the project. The team can recreate the deployment path carefully. They can study the original materials and copy the design, but they still cannot fully prove how the system would behave in a real-world accident without destructive testing. This is why the rebuild creates such divided opinions online. Every successful repair simultaneously proves the team's impressive skill, while also reminding viewers of the limits of what can truly be verified outside factory testing conditions. The custom interior also symbolizes something larger happening throughout the entire project. This Bugatti is slowly transforming from a factory-engineered product into a hybrid creation shaped partly by Bugatti's original engineering and partly by independent craftsmanship. That transformation is both exciting and controversial. For some viewers, it represents freedom, creativity, and technical talent overcoming corporate barriers. For others, it represents a gradual move away from what made the car special in the first place. Both interpretations exist at the same time, which is exactly why the rebuild continues generating endless discussion. The interior may appear like a cosmetic part of the project, but it actually reveals many of the deeper questions hiding underneath the entire rebuild. Another major reason this rebuild has captured so much attention is the work being done by Bob, who has gradually become one of the most respected figures in the entire project. Many viewers now see him as the technical backbone of the rebuild because some of the repairs required skills far beyond normal mechanical work. When the crash damaged the front structure of the Bugatti, the project reached a point where replacement parts were either unavailable or impossible to obtain through normal channels. That forced Bob into an extraordinary situation. Instead of simply replacing damaged sections, he had to recreate major parts of the front chassis by hand. On camera, the process often looks surprisingly calm and controlled. Bob cuts away damaged metal, measures structural sections, sources correct grades of aluminum, and slowly rebuilds everything piece by piece. The calmness of his approach is actually one of the most impressive parts of the entire rebuild. While viewers see one of the world's most expensive hypercars sitting damaged in a workshop, Bob often speaks about the repairs with the confidence of someone approaching any other fabrication project. He even compares certain tasks to previous work he has completed on other high-end vehicles. Watching him gradually rebuild sections of the chassis is fascinating because the work combines old-school craftsmanship with modern automotive engineering. By the end of many repairs, the recreated sections look almost indistinguishable from factory components. For supporters of the rebuild, Bob's work represents proof that highly skilled independent specialists can achieve results many people believed only manufacturers could accomplish. But at the exact same time, his work also strengthens the concerns raised by critics. The fact that a Chiron chassis requires hand-fabricated repairs outside the factory is precisely the scenario Bugatti likely wanted to avoid from the beginning. The issue is not whether Bob is talented. Few people watching the project seriously doubt his abilities anymore. The issue is whether visual perfection automatically equals factory-level certification and validation. Those are two very different things. A repaired structure can look perfect while still behaving differently under extreme stress, compared to the original engineered component. Hypercars like the Chiron experience enormous forces during high-speed driving, braking, and cornering. Small structural differences can matter far more at those performance levels than they would in ordinary road cars. Again, this creates a strange dual reality that defines the entire rebuild. Bob's work is both deeply impressive and impossible for viewers to fully verify. The project repeatedly places viewers in this uncomfortable position where they admire craftsmanship, while also recognizing the unanswered engineering questions that remain underneath the surface. The emotional side of the rebuild naturally pushes audiences toward celebration because watching impossible repairs succeed feels exciting and satisfying. But the technical side keeps introducing uncertainty that never fully disappears. That balance between admiration